All right, we talked about experimental probability yesterday just a little bit. Today we're going to go in a little bit more detail and hopefully get you to your work pretty quickly. Experimental probability is a little bit different than theoretical, because theoretical was what should happen. Experimental probability, the easiest way to look at it is what has actually happened. It's the probability based on what happened when we rolled the dice or flipped the cube or flip the cube. Maybe we flipped coins, not cubes. That's weird. Anyway, so experimental probability. Another way to put it, another description you'll see, another definition you'll see for experimental probability is relative frequency. And we mentioned that just the other day, but this is the probability, or how much something happened compared to the total number of times that we tried it. So our definition is just going to be what actually happened. So when we did the experiment, when we actually did the event, when we drew the cubes, when we flipped the coin, when we spun the spinner, whatever, what actually happened. So in this example, one of the ways you know you're talking about experimental is when it talks about the results of doing something. So this says, the table shows the results of spinning a spinner labeled A, B, C, D. Find the experimental probability of spinning each letter as a fraction in simplest form. Write it as a fraction and a percent. So step one, you look at the diagram right here. Here's letter A, B, C, and D. Here's the frequency. That means how many times it happened. So maybe we'll put that down here. How many times? So we got A 14 times, B 7 times, C 11 times, and D 8 times, which means total 14 plus 7 plus 11 plus 8 is 40. And that's the total number of times we actually tried spinning the spinner, because I added up how many results we got. We got 40 different results. So we'd spun it 40 times. And that's step one. We use the given information to find the total number. And don't put possible. We find the total number of trials that we ran. So we ran 40 trials. Second thing that we need to do is find the number of times that your desired outcome happens. Or in other words, find out how many times the thing you are checking the probability of happened. So it wants us to find the probability of each letter. And so if I look at A happened 14 times out of 40 times. So I'm going to put the probability of A happened 14 out of 40 times, our experimental probability. The probability of B, the probability of spinning a B, our experimental probability, we got 7 B's out of 40 spins. The probability of C, we got 11 out of 40. And the probability of D, we got 8 out of 40 spins. Okay, and that's step 3. We just put it in the fraction form. And on top, or I guess on bottom, we put the total. We'll fill it out like the notes. Put it in fraction form with the total on the bottom. And on top goes the number of times it happened. So maybe over here on the side, let's write a fraction. And on top, we'll put how many times it happened. And on the bottom, we're going to put total trials, how many times we tried it. And then we simplify the fraction. Sorry, you might have to pause and go back and write that part. Simplify the fraction. Write your answer as a fraction and as a percent. Okay, so 14 over 40, that's our fraction. But if I want to turn that into a percent, let me get this over here where you can see it. 14 divided by 40, I hit enter, that's 0.35. So as a percent, I move the decimal 2 places, 35%. Okay, 7 over 40, 7 divided by 40 is 0.175, or you can do the fraction, 7 on top, 40 on bottom, best friend, best friend button it, and you get 0.175. Move the decimal 2 places, and you get 17.5%. 11 out of 40, 11 divided by 40, 0.275. Move the decimal 2 places, 27.5%. And 8 out of 40, 8 divided by 40 is 0.2. And I know there's not a 0, but we have to move the decimal 2 places, so that becomes 20%. So right as a fraction of percent, really the only difference is this time, instead of how many times could it happen, we're putting the number of times we tried on the bottom and the number of times it happened on the top, which is this little fraction right there. So how many times it happened on top, the total number of tries on the bottom. A couple of things, couple of notes down here at the bottom. The total always goes on the bottom of a fraction. Total always goes on bottom. And what's interesting, and we'll talk about this a little bit more tomorrow, but the more times you do an experiment, the closer you get to the theoretical probability. So if I flip a coin twice, it's probably pretty easy to get heads twice. But if I flip a coin 100 times, I'm not going to get heads all 100 times. So as you do an experiment more, you get closer to the theoretical probability. All right, turn it over to the back. Excuse me. A couple of problems here on the back. Let me zoom in just a little bit, maybe help you see this a little better. A spinner marked with 4 equal sections of blue, green, yellow, and red was spun 100 times. Find the experimental probability of landing on green. Well, the problem already tells me I spun it 100 times, so that goes on the bottom. And on top, I want the probability of landing on green. And green happened 10 times. So that goes on top. And when I simplify it, if you can't do that in your head or you don't remember how, make the fraction in your calculator, hit enter, and it simplifies it for you. So that's 1/10, which is 10%. So that's my experimental probability of landing on green. What's the experimental probability of landing on red? Again, 100 goes on the bottom. And on top, red happened 68 times. And if I want to simplify it, 68 on top, 100 on bottom, I get 17/25. And as a percent, that's just 68%. Okay? Number 3, I like this one. What is the experimental probability of not landing on yellow or green? So we don't want green, we don't want yellow, which means we want red or blue. So blue's 14, red is 68. It really seems like red's happening a lot more often. There must be something going on with the spinner. That's not very even at all. So 68 plus 14 is 82. That goes on top. 100 spins goes on bottom. When I simplify that, 82 over 100 gives me 41 out of 50, which is just 82%. All right, pause the video. I want you to try these 3 problems on your own. When you get them done, come show me what you did, and good luck.